In this video I'm going to be just going through some of the little areas that haven't quite been covered maybe in the previous few videos on plane and descriptive geometry. So I've about 8 or 9 sheets in total here. I'm going to go through this, just starting off with really basic problems here and just going up to a few more kind of obscure and strange styled questions that are there that would have been more traditionally associated with the old Leaving Cert course. Nonetheless, we'll have a look through them. So in the previous 3 videos I've kind of covered a lot of what's on plane and descriptive geometry, simply inclined planes, section planes, oblique planes, and so on. I've also put a video out there on skew lines and intersecting planes and dihedral angles. So these are just kind of just tidying up the last few areas still left to cover. And look, I won't spend too long on this. I've no SolidWorks coming in for this video. It's just the worksheets only here. So let's just get going. First off here, find an edge view of the given lamina using the horizontal cut method. And in the second sheet then it's going to be find an edge view of the given lamina using the auxiliary method. So just quite simply 2 methods for finding the edge view of a lamina. And this isn't really going to take us long. So using a horizontal cut method just means starting in the elevation, cut the object horizontally. And it's quite easy this time because we have a point here to start with. So I'm going to start with this point right here. I'm going to cut the object horizontally. I'm going to call that point A. There's B and C. And A cuts across there to point 1. So that's A, B and C. And I want to find point 1, which is on the line BC. And that will be falling around there. So that's point 1. And the line A to 1 is my horizontal cut, or what can be called a strike line. So because it is a horizontal line in the elevation, it is a true length line in plan. If you look along a true length line, you get a point view of the line. If that line lies on a plane, you get an edge view of the plane. So that true length line right there in plan, if I view along the true length line, is it set up accurately? It is. If I view down along that true length line, okay, there's my viewing direction. If you view along the true length line, you should end up with a point view of the line and an edge view of the plane, and that is using the horizontal cut method. I'll drop in my x1, y1 perpendicular to my projections, and I never take compass marks without a line there, so I'll just link up my views here, my 3 points linked up, point C linked up, so I'll have some line to set my compass on, starting with the lowest point being point B, marked out from point B. Next one up being point A and 1, both at the same height, so A and 1 become a point view, and finally C up here at the top, marked here. So I end up with point B there, A, comma 1 there, and C out here, which should give me a perfect edge view of the plane. There we go. Okay, so there's my edge view. Now, that is the edge view of a plane using the horizontal cut. So cut the object horizontally here in the elevation, and that horizontal cut is going to appear as a true length down in plan. View along the true length line, and the line becomes a point, and the plane becomes an edge view. So there we go. If we wanted to find, just as an extra here, if we did want to find a true shape of the plane now, you could look at 90 degrees to the edge view, looking up or down. Or you could rabat it about that edge view, maybe rabat it about the point A1 there, the point you've line, and rabat it and then bring it back. But there we go, that's the question answered. Anyway, find an edge view of the given lamina using the horizontal cut method. And in the second sheet I'm going to go on to here, find an edge view of the given lamina using the auxiliary method. Now the theory here is the exact same, but there's just one extra step involved. What we want to do is, just like the last time, we want to get one line as a true length, one line as TL, and then look along TL. So it's practically the very same as last time, but we're not going to use our strike line, we're not going to use horizontal cut, we're going to just use what we have right there in front of us. So we need to find one line as a true length first of all, then we're going to look along that true length. To find the line as true length, well, look 90 degrees to the line. So I'm going to, first of all, actually I'll just link up my points, label my points, just so that I have a clear view of what's going on here. There's the few link ups there, and I'll just call this A, B, C here, and A, B, C here. I'm going to look at the plan instead of from my usual orientation. I'm going to just take myself around here, and I'm going to look at, what will I do? I'm going to look directly in at AB and project an auxiliary elevation. I could have picked any one to start with, so there's no reason at all. Pick for picking AB, pick whichever one you want. I'm going to take the angle of AB, and I always like to just show my projection angle, my projection direction. So that is the direction that I will be looking at this object right now. So there's my viewing direction, perpendicular to the line. Okay, so we're viewing perpendicular to that line right there. I'll project off B, I'll project off C, and I'll project A, and I'll drop in my X1, Y1. My projections are at 90 degrees to my AB line, and my X and Y1 are at 90 degrees to my projections. So let's take the heights of the 3 points again. Height of A, height of B, and the height of C. And my points. So that was A, B, and C. Now what you'll notice this time is I don't have an edge view, but what I do have, I have a view that shows the line AB as a true length. So it's just one extra step really this time. I preferred horizontal cut method, but you know, this one is relevant and it's valid. So I have a view showing we've looked at the line AB, and it is the true length of AB. So as it sits in that view right there, it is a true length. So what do? We look along a true length line. So I'll set the angle of my true length line right here. These worksheets are so small that it's really hard to keep them accurate. So just do your best to make sure when you're setting the likes of the adjustable that you set it as accurate as possible. That's my viewing direction right there for this next view. So I'm viewing along the TL. So view along the true length line, and 1 second now, it's moving a little bit. Set the angle of AB, view along the true length line, project my second point, drop in my X2, Y2, and the near one first, the distance back to C. So we're looking for the dimensions up here, skip one view and work back. Distance up to C is there. distance up to B is there, and A is the exact same as B. So we get, should use orange again, that is A and B right there, and that is point C. So there we have it. In using the auxiliary method, I have found an edge view of the plane. Okay, so there is our auxiliary method. So use first auxiliary to show the true length of one of the edges, then look along the true length to find a point view of that line and an edge view of the plane. So there's an edge view. And there we go, that's that question done. So really, as you can see, it's a bit of quick fire now in these. That's the horizontal cut method and the auxiliary method there finished. Now find the shortest perpendicular distance from the point P to the lamina ABC. What do we need to do there? What we need to do is we need to find an edge view of the lamina. If we can find an edge view of the lamina, we will be able to find the perpendicular distance. Okay, so edge view of the lamina is what comes first here. I'm going to start off, my preferred method here for the edge view is the horizontal cut. It cuts from C over to point 1. Point 1 is on the line AB. Point 1. And right there I get my true length line. That's the true length line on the surface. So I'm going to look along the true length line on the surface. I'll view along the true length line on the surface in that angle to get an edge view of the surface. I'll take point P out there with me as well. I'll bring in my X1, Y1. I'm going to link up my views actually as well so that I can take accurate compass measurements when I'm setting it this time. Point P right there and point B finally. For my elevation out here, I'll take the original heights from my elevation up to point B. Label as you go if you want to. I usually, sometimes for these easier drawings, I'll just leave all my labels until the end. There's point C, point P, and point A. So I have A, I have B, C, that's point P right there. And what does that give me? That gives me an edge view of the plane. Okay, and there's my edge view of the plane right there. What else do I get? Well, I want the shortest perpendicular distance, so from here I can get the shortest perpendicular distance straight away. I can just draw the perpendicular line perpendicular to the edge view of the surface. If I'm getting a perpendicular distance from point P, it's perpendicular in every edge view. So no matter what view I take, as long as it shows the plane as an edge view, the line from P will appear as a perpendicular line. So I can I'll just drop that in there with a different color for now. I'll just get sliding set squares here to do this. I'll set the angle of the line of the ACB right there, which is the edge view of the plane, and I will drop in my perpendicular distance. So there we have it. Find the shortest perpendicular distance from the point P to the lamina ABC. But that's not quite me out of trouble yet, because I'm not there. I don't know yet where that line lies. I'm going to call that, I already used the label 1, I'll call that point P to 2 right there. And I need to see exactly where that lies. So how do I do that? This is going to get a little bit messy now, but possibly will anyway. I need to project a true shape, our second auxiliary showing the true shape of the surface, and then I would be able to find exactly where P and 2 are. So let's go for it. Let's just see what happens. I might just do all this in a different colour so that hopefully when it does overlap the other drawings it won't look too confusing. I'll take that edge view of the surface right here, the line ACB. I'll set that on my adjustable. I'm going to go with yellow here for this. Hopefully it won't, as I said, don't want it to get too confusing here. I'll take this thing, I'll take A, project it up, C, project it up, B, and P. Now, as we can see, that's a true length line, and if you look along a true length line, it should become a point view next time. So let's see if that happens. It should happen for us. I'll take these right up as far as I can. I don't want them to be drawn over the plan if I can avoid that now at all. I'll just set up just above the plan here maybe. I know it's going to look a bit messy, it's going to go over my elevation as well. But there I get that was X1, Y1. There's my X2, Y2. Where do I get my distances from? So what we're looking at is, if we're projecting from this view up, I'm going to skip a view and work back from my X, from the previous XY line. I'm going to work back to point C right here and up to point C in this view, back to point A, and I'm going to go up to point A, back to the plan here to point P, up to point P, and B, the final one. Now, I'm going to use blue for this one, just as hopefully it'll look clear if I just do it in a different colour. That is point A, and what else? That is point B out here, and that is point P right here. So let's draw the shape. ABC is the true shape. I have just looked at 90 degrees to the edge view, so I have found ABC as the true shape of the surface. Now, what else have I? I have point P. That's where point P is going down, and if we have to we have to ignore what we can see here in the elevation at the moment, and we have to see that that is the point where P and 2, so the pink line going from P right down to 2, so I probably should have that colour dropped in there in pink as well. That is the point view of the line. Okay, so P and 2 are falling exactly on that point. What does that mean for us? That means that I can take the distance back to, I'm going to call that P and 2 there. If I just put the two labels on it, P, comma, 2, I can take the distance out there to P and to 2. Okay, and I can bring it back from point 2. So I need to take my original projection angle right here. Where was it? Just use sliding set squares for this one. Take my original projection angle from my first auxiliary, project back point 2, going back this direction. And take the distance up to point 2 and mark it from here back. There's the line P2. Okay, shortest perpendicular distance from the point P to the lamina. Next, I'm going to have to find point 2 up in the elevation. So how do we do that? First of all, project point 2 up to the elevation. And I just take my information like I would always take. I'd take the height of B in the elevation and mark it to the auxiliary. Well, this time I'm just doing it the opposite way around. I'm taking the height of 2 from the auxiliary and marking it up into the elevation right there. So that becomes point 2 right there. And there we go. That's the question answered. Find the shortest perpendicular distance from the point P to the lamina ABC. Now, the way the question is kind of worded is a bit odd in a way, because find the shortest perpendicular distance is strange because there is only one perpendicular distance from a lamina to a point. Okay, what we have to imagine is that in every view we take, that pink line is sitting at 90 degrees to the plane. So there is only one possible perpendicular distance. So it could be worded just without this shortest part here. Find the perpendicular distance, or it could have just said find the perpendicular line. And it all comes from the edge view of the plane down here. So that's an edge view of plane. Edge view ABC. And from the edge view then I can get my perpendicular line, and when I bring it back I can just use my true shape then to prove that the distance down to P and the distance to 2 has to be the same. Now we could also, it's not an assumption as such, but I prefer to prove it using my true shape, but we can also realize that because it's a true length line here and it's going to be a point view, that it's going to fall in, should fall in there parallel to the XY. Yeah, it should fall in parallel to the X and Y one as well, but I'd prefer myself now just to spend a few seconds to get my true shape and prove that it's correct there. So the distance back to P and back to 2 being the same, project back down here, distance back to P and the distance back to 2 being there. Finding the height of point 2 in the main elevation from the distance taken in your auxiliary elevation here. So that is the short, we'll call it the shortest perpendicular distance, but really it's the only perpendicular line from a point to a plane. Okay, so that's that question done, just in case something like that ever came up. Now this one, find the shortest horizontal distance. So this one is a valid question. I'll find the shortest horizontal distance from the point P to the lamina ABC, because there is an unlimited number of horizontal distances from P to ABC. So we want the shortest horizontal distance from the point P to the lamina ABC. It's actually quite an easy question, I think, really. What I'm going to do is this. I'm going to just work with the portion of the question that I wanted to work with. I'm going to work with that only. That is a horizontal section. And that horizontal section is going to give me my answer, because that horizontal section cuts through the plane from point 1 to point 2. Point 1 is on the line BC, just there. Point 2 is on the line AC. I need to be careful now with this one to get it onto the line AC. Down here is point 2. And what is produced by that section is there. So that is the portion of the plane that is cut by that horizontal section plane, going from point 1 on the line BC, point 1 on the line BC, to point 2 on the line AC, point 2 there on the line AC. And I always talk my way through them because I don't want to make the simple mistake of putting point 2 up in the wrong line. So what do? We want the shortest horizontal distance from the point P to the lamina. So basically what we're asked is this: the shortest horizontal distance has to land on this orange section someplace, because that's the horizontal section. Find the shortest distance between that point and that line. That is basically what we have now changed the question to. So we can just go ahead and take our sliding set squares right there, and run off at 90 degrees. And there we go. That's the answer. That is the shortest horizontal distance from the point to the lamina. It takes us in there to point number 3. Point number 3 lies on the line from 1 to 2 there, on the orange line. Point number 3 lies on the orange line. So the projections of the shortest horizontal distance is, I should use my T-square for this. There we go. Shortest horizontal distance from a point to a lamina. Now, next one. Draw a line from point A which will make an angle of 50 degrees to the edge BC is this question, and this next sheet after that is in draw the projections of a line on the plane ABC which is 30 mm long, starts at B and finishes on the edge AC. We need to realise that there's something in common with these questions, and that there's a few more ways that they could be posed as well. They're asking us to do something on the plane, so draw something on the plane. Now whether that is draw a line from point A which makes a true angle of 50 degrees to the edge BC, so when that line is drawn, the true angle that line makes is 50 degrees. Or in the previous one, draw a line starting at B touching the edge AC that is 40 mm long. And again, it's a true length, so it has to be seen as a true length line. Maybe it's draw the largest possible circle that fits into the plane. Draw the smallest possible circle that circumscribes the plane, touching points, the 3 points there. Or this could, there's a lot of different ways that this could be asked, but they all revolve around the same thing, the true shape. Everything here is about the true shape. If you want to see a true angle, a true length, or a full size circle, or the smallest or biggest possible circle, we need a true shape. So let's go ahead and find an edge view and then a true shape. So I'm going to get a horizontal section here. So I know it's very inaccurate there. Horizontal section, cross through A, gives me the point 1 here on the line BC, and actually I should really start with these worksheets by just linking up all my points. Okay, point 1 is on the line BC, point 1 on the line BC, 1, and I'm going to be viewing along 1A, right there. So that 1A is a true length line on a plane. I'm going to view along in that direction, sorry. There's my X1, Y1. Height to C. A and 1. If we look along a true length line, it becomes a point view. So there's A and 1. And finally, B. So I get C, I get A, 1, and I get B right there. 3 of them together give me an edge view of the plane. From that edge view, I'm going to set my adjustable again. I'm going to look at 90 degrees to the edge view. So take the setting of our edge view, the exact angle, and that T-square is just that little bit dodgy. There we go. Project 90 degrees to the edge view. There's AM1, there's B. And draw your X2, Y2. Take the distances, So we want them here. So actually, and the other point that we should be making here is this, okay? This is an elevation, and this is a plan. If you project from a plan, okay, in that viewing direction, you project from a plan, it becomes an elevation. When we project from an elevation, it becomes a plan. Okay, so it's always every second one really. It's elevation, plan, elevation, plan. The distance for one plan has to come from another plan. Okay, and the big mistake I've seen here a few times is this. Okay, this, if you just go by that logic only, this distance for this plan has to come from this plan, so they come down from this xy. Well, that is never going to work. And have a look at my previous 3 videos on planes if you don't understand why. The linking has to come by skipping the view and going to the x and y one and working back. So back there to point B, out to point B. Back here to point C, out to point C, and back to point A, and out to point A. I don't need to take one with me this time. Anyway, there we go. There's the true shape of that lamina A, B, C. Few labels to be dropped in, and that is A. Well, I already have one, of course. That's my one right there. If it's a point view here, it's a true length here, falls along. We'll be looking along it to get the point view. A, B, and C. Now, what are we actually asked to do? Draw a line from the point A, which will make an angle of 50 degrees to the edge B, C. So, a few different ways to do this. What I'm going to do is I love these adjustables. I think they save us so much work. I'm going to set my adjustable to 50 degrees. First of all, I'm going to just figure out which one is 50. Is it this one or this one? Well, it's going to be, isn't this going to be this one here? It is. So it's this side here is 50 degrees, but that's not going to work for me. What I'm looking for is an angle of 50 to the edge BC. So I'm going to just turn my adjustable there and have it ready to go. I'm going to get my sliding set squares here. Okay. I'll take the angle of BC right there, and I'm going to just take that angle, okay, and slide back by a little bit. I have a line now. My set square is parallel to the BC edge. I'm going to bring my adjustable, which is set at 50 degrees, in on top. It's not quite far enough there, so I'll just slide back just that little bit further again. Take it away a little bit further, bring your adjustable in, and draw your 50 degree line. And there we go. So that's kind of a nice handy way of doing this. There's my 50 degrees right there. It's a really fast way of doing it, I think. Your second option would be this, okay? So that's just using the adjustable and just doing it all in one single step, which is just, as I said, it's really fast. And that's the correct line right there, making a 50 degree angle. So if you get that, that's brilliant. You've all solved in one step. And if you don't, and if you find the adjustables a bit harder to work with, maybe do this. Okay, I'm going to extend on the line BC, just make that a little bit bigger in each direction. And from one of the sides, maybe from point B there. Okay, from point B, I'm going to set an angle of 50 degrees. Okay, and if I just, there's a 50 degree angle. Okay, take your 50 degree angle then. So that's a 50 degree angle to the line BC. Take that angle and bring it in to point A. So, you know, either way it'll work. Just my initial method there just was only one single step, so it was a bit faster. If you don't really get that, or you don't have an adjustable to work with, maybe go ahead with your protractor, mark your 50 degrees off any point at all on the line AB, or even outside the line. Set the angle and slide it in. Now, there we go. What else should we do at this stage? We really should take this blue line back through our views as well. It says draw a line from A which will make an angle of 50. It doesn't say draw the projections of the line, so I've actually solved this question right now. I have ticked the box there, draw a line from A which makes an angle. I've done that. But just to be safe on the marks, I would always just draw the projections of the line, and I'm quite sure that that's the way it would be mentioned in the leaving cert if it came up that way. I'll set my angles. I won't bother with the adjustable this time. I'll set my angles and just bring that point back through the views. So that point, I'm going to call that, what numbers have I used? 1. That's point 2, A to 2. Point 2 lies on the line BC. Okay, bringing it back to plan. Point 2 lies on the line BC, which is point 2 right there, and bringing it up to elevation. Point 2 on the line BC. There we go. Let's get this line drawn. So it's a line that joins A to 2 is my 50-degree true angle line. Right there, A to 2, and up here in the, that's in the plan done, and up here in the elevation. There we go. Now, that's the projections. So I've definitely satisfied the question now, but I had it already done here. So that's drawing the projections of the line, which is a true angle of 50 degrees to the edge BC. Next page. Draw the projections of a line in the plane ABC, which is 30 mm long, starts at B and ends on the edge AC. So let's go for it again. Let's go, same rules apply as the last time. Let's find our strike line first of all, which is a horizontal section cut. We'll take that point 1 down onto the edge AB, isn't it? Yes, it is. Onto the edge AB, there is point 1. And that's our angle. And before I go ahead and start working on auxiliaries, I'll just link my views. I'm going to set the adjustable to the angle of C1. And project out in line with C1. So I'm viewing along C1. Along the true length line. And that line right there is the true length. I'm setting up my X1, Y1 perpendicular to my projections. I'd be so surprised if this is not some way inaccurate now. Everything is so close to each other. But we'll go with it and see what happens. We have the distance out to A. The distance out to C and 1 being the same. Of course, it's horizontal here, so C and 1 are the same. So the line C1 becomes a point view. And we have our distance out to B. And that gives me the edge view. So small there. There's A, there's C and 1, and there is B right there. That is tiny. Let's just keep going with it. I was planning to do a rebatment here at this stage, but it's so, ooh, I try it, I won't. It's just so small that if I do a rebatment here, it'll be very hard to pick up the details. So look, I'll just keep going with it. I'll set the angle of that edge view, ABC right there. Just check it a second time. Measure twice, cut once, you know. Project out from my 3 points. There's my X2, Y2 line for my next auxiliary, and skip one view, work back. So distance back to A, marked down. Distance back to B, marked down. And finally the distance back to C, marked down. I get my points A, B, C. And we'll join the dots and draw the plane. There we go, that's a true shape. Of ABC. Now, what have we actually been asked to do? Draw the projections of a line on the plane ABC, which is 30 mm long. Starts at B, ends on AC. That's fine. I like to just, okay, I'm setting my compass to 30. I'm going to work from the corner of this border here, and I'll just mark the page at 30. I really don't like setting a compass on a set square. I think it's very bad practice. From the corner of the page, this takes a couple of seconds longer, and at least you know it's accurate. What are we asked? So I have my compass set to 30, start at B and end on AC. Can it go either side? No, it can't. It can only be this one right here. There we go. I use my compass because as I plot out this curve from B, it is every possible line from B that is 30 mm long, and then I find the one I want right there. That really solves the question for me. I've used the label 1 already. There's the label number 2 right there. The line there that goes from B to 2 is 30 mm long, and it lands on edge AC. So I've solved the question. And again, draw the projections. It's worded correctly this time. Draw the projections, meaning all projections, means show it in all views. Let's take that back to the views. And I'd usually use a different colour here, but accuracy and all that, I don't want big thick fine liner marks. I need to keep this fairly clean now because the drawing is the margins are so small here in this drawing. I'll take my angle back to the original plan of the point where it lands in the edge view there, and that was on what? What was that on? AC, wasn't it? The AC is down here, so it's way in there near the corner. That's point 2. I'm going to draw that in the elevation as well before I actually draw the line. I'll find point 2 in the elevation right there on the line AC 2. Then, last task. Join B to 2. Once and twice. And there we go. That's that question answered. So draw the projections of a line on the plane which is 30 mm long, starts at B and ends on AC. Now, as I said already, the hint is in the question here, okay? A line on the plane. If it's on the plane, sorry, A, B, C. But if it's on the plane, we need to see the true shape of the plane. If it's on the plane as a true length or a true angle, we have to see the true shape, okay? That's the big thing here. Okay, for a true length, you have to see a true shape. For a true angle line, you have to see a true shape. Or for a circle, maybe, you have to see a true shape. Or, of course, if it was a polygon. If they said draw, if it was find the largest possible hexagon that fits within the shape, well, you'd start off by finding your circle and then you go ahead and you construct your polygon in the circle, maybe. So that would be it there, okay? That would be that question solved in a couple of different scenarios. I think polygons wouldn't really be a common one. Circle certainly would. So find the largest possible circle that fits here. Well, you'd bisect your angles and so on, and bisect your angles and draw your normals, and then you get your circle, you know? So it could be something like that. It would be highly unlikely that they'd ask you to find the projections of that, though, because that would mean splitting it up into your 12 points and bringing it back and finding a freehand curve here in plan and a freehand curve here in elevation. So that's highly unlikely that you'll ever see something like that. But just finding the actual circle itself, very likely. Just a skill you'd need to have and a bit of knowledge of the principle that you'd need to know. That's it for this sheet. I think I have 3 more now, so I'm going to pause the video, get these 3 stuck on, work through them, and as far as I know, that's going to be the end of playing descriptive geometry, unless I get any comments or suggestions for more videos that you need to see. Now, here we are at the third last question on this little short video here, and we are talking about drawing a line from a point P which will touch the lamina ABC. That sounds easy, doesn't it? But it has to be a total of 90 millimeters long, so that's true length 90 from point P, and it has to be inclined at 45 degrees to the horizontal plane. So it's one particular line, and there's only one possible answer. The point P that will go down and join someplace, and the true angle that makes with the horizontal plane will be 45, and it has to be a true length of 90. So there's a few constraints in here. Let's loosen those constraints a little bit first of all. Let's just work with a cone. We'll just work with this, okay? 45 degree angle going both ways there. What I've realised as well doing these, and I should pass these out to various to students at various times, these are set up to be an A3 page, which would be A3 would be 90. So for this, I'm going to go with 45. Alright, so hopefully, yeah, I think that should work. So I'm going to go 45 mil there. So I'm drawing a cone. It's 45 degrees to the horizontal plane would be the true length of any generator on that cone, and that's it. It's the true length of the generator is 45 mil, and the true angle it makes with the horizontal plane is 45 degrees. So I'm kind of solving part of the question and just relaxing the question just that little bit, and I'll build up towards the answer instead of trying to get it all in one go. So that right there is a cone, and it's a cone that has every single generator 90 mil long, and every generator of that cone is a 45 degree true angle to the horizontal plane. I'm going to draw that cone in plan. Okay, so here's my cone in plan. And the cone in plan, of course, appears as a circle, and there we go. So down there in plan, every possible line from P down to the base of the cone is 45 mil long and is at a 45 degree angle to the horizontal plane. Now, let's start anyway. Working ahead from there, I'm going to get an edge view of the plane, like I always do, like I have done for the last number of pages as well. It cuts from B over to point 1, which is on AC. Point 1 on the line AC is right there. Point 1 on the line AC. I'm going to take the angle of, what is it, B to 1. I'll take the angle B1 and turn that. So I'll take the angle of B1 and that's accurate there. So angle B1 there is my strike line. I'm going to view along that line. So we'll view through that line at that angle. I'll take the point A. I'll take B and 1 and C. And let's not forget what this question is all about. We'll take point P. There. I'll drop in my X1, Y1. And up here, I forgot one of my own key steps here. We can't go setting a compass unless we have a line to set it on. So I'll link up my points there in the two views. There we go, all linked up. I'm going to take the distances, so I've projected from a plan, so this is an elevation. I'm going to take the distances from one elevation and mark them onto the other. Is it all going to fit on my page? Ah, yeah, it is, I think. That is point C right there. That is point B, which lies here in the second projection, and point A on that third projection to the right there. Then point P up at the top. And that is here. So we get points A, this is B and 1, I'll just label it as B at the moment. That is C, and that is point P up at the top. I can draw ABC as an edge view of the plane. So there we go, edge view of the plane drawn. I have point P, and I'd like to draw my cone. So I had my cone already down here. I had my cone elevation, which showed every possible 45°, 45mm line I had it shown in plan. So let's show it here in the auxiliary. So I need to take my, where was my viewing angle? I had set this way. I need to take my viewing angle, and I need to do this first of all. I need to take my viewing angle and just go left and right at 90 degrees to it, which gives me the extremes of the cone. And I'll just project that up to this view here. That's the extreme left of the cone and the extreme right of the cone. I'm going to take the angle of the ground, the XY, or the X1, Y1 I should say, here. Take the angle of the ground, and I'll mark off 45 degrees from there, because it's a 45-degree cone based on the horizontal plane in every possible view. So there's the cone. That's the cone in that view. What I'd like to do now is I might pause the video for just a few seconds, add a little bit of colour onto that cone, which will hopefully make it a bit more easy to understand and see what it is. And there we have the bit of colour added in, so we can see our cone in the elevation and in the auxiliary elevation. We can see it here in plan as well, of course. Now the important thing is this. Where does the cone hit the edge view of the surface? It hits it right here. Okay, and where the cone hits the edge view of the surface answers our question. Every possible generator on this cone is 45mm long, and every generator on the cone has the same angle as the cone, which is 45 degrees to the horizontal plane. So that generator right there solves the question. It's the generator that coincides and hits the edge view of the plane. Let's project back down. Let's check my angle again. How good I get set? No. These adjustables can move when you're drawing and you're working away. The adjustables can easily move. So make sure before you just trust that it's correct. You just check it every time. You know, if you put it away for a few minutes, check it on the way before you come back drawing again, you know. And that seems to be set quite good there. That generator from P down to, I'll just call that point ABC, I'll just call that point D right there. The generator that goes from point P down to D, well, point D is on the base of the cone, so it is down here. That is point D right there. So point P down to point D right there. Okay, that is the generator that solves that question in plan, and we want to draw that in elevation, so point D there is just about inside the extreme generator in the elevation. There's point D. And there we go. So we've used the cone to solve a question, something like we're really used to doing in DCG. So draw a line from the point P which will touch the lamina ABC at a distance 90mm, but as I said, that would be if this was an A3 page, but it's printed for me as an A4, so I have the size down to 45. And it is inclined at 45 degrees to the horizontal plane, just like every generator on this cone. That's that question solved. So that is it for today's video, and there's actually quite a bit gone through there. What I expected would be a really short video has ended up having quite a few questions and worksheets in it. Starting off with our horizontal cut method for finding an edge view of a lamina. That has kind of formed, that and the auxiliary method, they've form the basis for everything in this video really. Finding an edge view of a lamina using the auxiliary method. As I said already, it's not really a method I practice too often. The horizontal cut, the one step, is a really fast way, efficient way of doing this. Then working with the shortest horizontal distance. I could of course have looked along this as well and found an edge view of a plane and then a horizontal line parallel to the x1, y1. No need. That's a very nice fast way of doing this. Working on from there, draw a line on the surface. A line on the surface at a given angle, and then we had a line on the surface. Sorry, this was the shortest perpendicular distance from a point to a lamina. That was another one we went through there. Again, there's probably no need for that blue view there, because we can assume that when we look along the true length line that the perpendicular distance is going to be perpendicular to the true length line, or the strike line, parallel to the x1, y1 line, as I said at the end of towards the end of that video. Next thing there then, and the final one I went through was this one right here. So draw a line from a point P which will touch the lamina ABC at a distance of 45 mm from P, and it's inclined 45 degrees to the horizontal plane. So just adding in some extra difficulty really in them questions, and just taking it on a kind of a step past what we would have seen in my previous videos. As always, thanks very much for tuning into this video. I'm hoping that it was helpful with just going through some of the basics and some of the more difficult questions here. If there's anything else that I can help with, if there's any more videos you'd like to see, drop a comment down below and subscribe to the channel. Thanks very much.